Okay, this is our 6.2 activity 3. So here it says we are going to graph the data that is given. We're going to use the graph to test the truth of each statement. If the statement is true, we're going to write an equation that will go with that to obtain one measurement for the other measurement. So letter A says, you can find the horsepower of a race car engine if you know its volume in cubic inches. So is that a true statement or not? So what we're going to go through and do is we're actually going to go through and graph this information. So if I graph this, remember these are my X's and my Y's. So I'm going to go over to 200 and up to 375. So this right here would be 300. So 375 is going to be just under my 400. So where those would intersect would be right there. Okay, then I'm going to go over to 350, which this is 300 right here. So 350 is in the middle of that box, and up to 650. So the middle of this box, and where they would intersect would be right there. Then I'm going to do 350 and 250. So 350 in the middle of the box in front of 400, and up to 250 would be right here. And then over to 500, which is this line here, and up to 600 would be right there. So now we're going to ask ourselves, do we see a pattern within those dots? No, it kind of looks like they're all over the place. So the question says, or the statement says, you can find the horsepower of a race car engine if you know its volume in cubic inches. Well, because we can't see a pattern, we can't write an equation for that. So this would be a no, this is false. Okay, so let's go ahead and look at the second scenario. So our second scenario says you can find the volume of a race car engine in cubic centimeters if you know its volume in cubic inches. So we're going to go ahead and graph all of this information. So we're going to go for the first one, we're going to go over to 100 and up to 1,640. So this would be 100 and 1,640. Well, this is 1,000, so it's probably about 3/4 of the way up. So there's our first dot or point. Then we're going to go over to 200 and up to 3,280. So this would be our 3,000 line, so a little above that. And then over to 300. So here's our 300 and up to 4,920, which will be just under 5,000. So it looks to me like we have a pattern going there. Almost looks like it's a straight line. Remember, each of these blocks was worth 1,000. So it was kind of hard for us to go through and actually see like how much it was changing. So we're going to check our change in our X's and our Y's. Remember, our slope is change in Y. So if we take one of our Y's and subtract another over a change in X, we can see how much it's changing. And then just double check that to make sure that that pattern's working elsewhere. So my X's is pretty easy. Just remember that goes on the bottom. That was a change of 100. It was going up 100. And then to find the change here, I'm going to subtract. So I'm going to take 3,280 and subtract 1,640. Looks like it's jumping 1,640 each time. So I should double check to make sure that this has the same change. So I will do that. And this would be faster with a calculator, but I'm just doing it so that you can see how I'm getting my numbers. So I did get the same answer for each. So our change was 1,640 over 100. So if I went through and actually divided that out, I could then divide 1,640 by 100, and that would give me 16.4. So we are changing 16.4. That would be our slope, so it'd be X, so our equation would be, well, our Y equals 16.4 times X. So that's the equation. So if you see a pattern, well, then we're going to go through and see if we can write an equation. In this situation, to write the equation off of the graph was really hard. So it was just easier for us to go through and actually find our change in y and over change in x. And we can see that it was going to cross through 0, 0. That's why we don't have anything in the back end here.